All right. Hey! Okay, we ready? We good? On our Hey everybody, today is an anatomy lesson as a follow-up to our last episode.
Hey, I'm Dr. Michael Squires.
And I'm Dr. Carly Squires.
And this is Dr. Squires Squared.
This is a channel where we have candid and casual conversations about anything and everything audiology.
And if you don't know what we're talking about, stick around. We'll tell you all about it.
All right, on our most recent episode, we had discussed one of the tests in our battery called Otoacoustic emissions, or OAEs. And as promised, we are back today to show you a little bit of an anatomy lesson and a walkthrough as to what exactly is happening anatomically when we are doing an OAE test. And Professor Dr. Squires here is going to kindly walk you through that now.
Here we go.
All right, so here we are looking at the inner ear again. If you remember from our last anatomy video, we looked at, this is a still shot of what we were looking at in the 3D version or 3D model. What we've got here is the tympanic membrane, or the eardrum, the little bones that are responsible for transmitting that sound from the eardrum into the inner ear. And then this is the cochlea. This is actually the little bony structure that houses the organ that is responsible for hearing and hearing sensitivity. So we're actually going to do a little zoom in here. We're just going to jump to a cross section of this organ. Okay, we've jumped to a different picture here. This is, I've got a lot more writing on it, but it breaks down each of the things that we're going to talk about all in one. So I like to use it. This is a cross section of that little cochlea, that snail shell bony structure we were looking at. And if you'll notice, there is 1, 2, 3 ducts for each turn. And there's 2.5 turns. So you've got 1, 2, and then this up here makes up the final half turn there. So if we zoom in on just one of those cross sections, you can see we'd be looking right in here. This is a cross section of just one of those canals. Now those canals have a membrane or a membranous labyrinth inside of them that's made up of 3 different tubes. There's the scala vestibuli up here, the scala tympani here, or what we know as the scala media, or the cochlear duct right here in the middle. This is where all the magic happens when it comes to hearing. You'll notice there's a cluster of cells down here, some structures that we're going to take a look at more in depth. And you can see that little box. That's going to jump over to here. Okay, so this is what's called the organ of Corti. The organ of Corti is a bundle of cells and nerve fibers that are responsible for transferring a fluid wave into an electrical signal that your brain can interpret. So we've got 1 row of inner hair cells. See right here, 1. You've got 3 rows, 1, 2, 3 rows of outer hair cells. What we're typically measuring with hearing sensitivity in terms of the distortion product otoacoustic emission is the health of these outer hair cells. Okay, so the way that this works, you've got a membrane along the bottom here that these cells will rest on. That's called the basilar membrane. There's another membrane, you can see the start of it here, but if we jump back over to this side, you can see that membrane extending up here. Okay, that is what they refer to as the vestibular membrane. We also know that as Reisner's membrane. That makes up a big triangle of membranes, if you will, that's filled with fluid. So as the sound wave travels down that fluid, it moves these membranes up and down. And as that membrane moves up and down, there's yet another membrane here called the Tectoral Membrane that's connected to these cells. So as this all shifts back and forth, it's moving little hair fibers on the top of those cells, or what we know as hair cells. That's why we've called these outer hair cells. So as those get moved, it sends an electrical potential down this neural fiber to a little cluster of neurons that then kind of accelerates that through the 8th cranial nerve to the brainstem and up to the temporal lobes where it's interpreted as sound. So what we're measuring with a distortion product otoacoustic emission is the response of these little guys right here. So we're measuring different points along the cochlea that are associated with different frequencies. So we'll measure anywhere from about 1500 hertz all the way up to about 8,000 hertz and sometimes beyond that with a distortion product otoacoustic emission. So as the sound comes in, these little guys act like an amplifier, and these cells will extend and push that tectoral membrane up and down so that the inner hair cell, which is located right here, can do its job in transmitting the large majority of the hearing to the brain. So when these extend out, stretch, and then they contract back in, it sends a little teeny ripple back out the way that the sound wave came in, which will extend back out into the middle ear and then out into the ear canal where we will measure it. All right, here we are back at the overall view of the inner ear, the balance system, the little bones in the middle ear and the eardrum. So the probe that we're using to measure sits right in here, right in the ear canal. The measurements are coming from these little neural fibers, those little outer hair cells that are located in that blue duct or the blue membrane that's represented here. That little ripple, that little response will travel back out of the cochlea, will vibrate the little bones, vibrate the tympanic membrane or the eardrum, and then is picked up at the level of our machine. Now this is a very, very slight response, which is why it's really important that the environment is really quiet. As an example, from the point here to the eardrum, when crossing these bones, that response is losing 30 decibels of energy. So the quieter the environment, the quieter the patient, the better responses that we're going to get. But that is the anatomy of the distortion product otoacoustic emission. We put sounds into the ear, which vibrate the system. They vibrate the basilar membrane, which corresponds to a certain grouping of cells at some point along the cochlea. Those outer hair cells will give us a response back, which then travels back out of the cochlea, across the ossicles or the ossicular chain, and back out into the ear canal where we measure it. It's important to remember the distortion product otoacoustic emission does not give us any information about hearing sensitivity. It's merely a measurement of outer hair cell function or cochlear health. If somebody has a mild hearing loss, they may still have these responses. And conversely, if somebody has normal hearing that doesn't show up on our standard hearing test, they might not have any responses. So like Carly said in our last video, it is a tool in our toolbox that we can use to reinforce some of the information that we've gotten on our other tests.
All right, everybody, that's a wrap. We hope you enjoyed our video today. Leave us a comment, like, share, subscribe, all that fun stuff. If you have questions, email us at info@hearwv.com or call our office at 304-428-2403. Have a nice day.
See ya.